Okay, guys. Okay, let me take the camera a little bit up so you'll see the paper. And I hope you'll forgive me for the amateur setup, but this is the best I could do for now, I guess. Anyway, I hope you all can hear me. Just let me check it out. Yeah, it's the least professional way to do it. I open the stream at my phone. Okay. Okay, so this is my setup for the calculation of the radius of the Earth, from extracting it from data gathered by MCToon and Dave McKeegan at the final experiment in Antarctica about 3 hours ago. I watched them doing it live, and MCToon said on his live, which ended abruptly several minutes ago, he said out loud what the data is, and you can see it. Their location is 79 degrees south, 44 minutes and 24 arc seconds. I'll translate to decimals soon. And the result of the experiment, and I hope the snow is level as far as it can be. The height of the stick is 195.5 centimeters, and the length of the shadow is 8 meters and 28 centimeters. It's like crazy. I hope you can see it. And I have it with me, the pen to do it. And I'll put a calculator on the screen so you can see what I'm doing, and if I have any errors on my calculation, I have it drawn and everything. If I have any mistakes, please notify me live so I can see what's going on there, okay? Now, I'll open the calculator so you can see it on the screen. And if you have any questions, any comments on what I'm doing, please let me know. Okay, so okay, I'll put it here, a little bigger, and I will add a okay, where it is? No, it's the second screen. And no, the cursor is not needed. Okay, now I will do like this, and like this, and like this. Yeah, the Hebrew letter says it's a scientific calculator. To those of you who don't speak Hebrew or can't read Hebrew, in Hebrew the word says madai, which means scientific. Anyway, you can see all the functions here, which basically most of what I need is trig, so I don't think there will be any trouble. Now let's see. Okay, 1 second. When ameliorative, when small people cast long shadow, it's yeah, I know. It's a very nice quote. Or you're in Antarctica. It's not means the sun is setting. The sun can be rising, but you're in the North Pole or the South Pole. Anyway, let's go do the trick. I hope you can see everything, and if something is not visible well enough, let me know. I know you can see the the pry here. It's not something that I can, you know what, I can. Okay, I hope it's better now. This. Okay, now let's do it. So we all know this is our globe. You can see it, and I flip it so I won't be needing to draw everything in the south. So this is the South Pole. They are at 79, like about 10 degrees from the South Pole. So let's say it like here. The sun is at due north. It was midnight. Okay, so we know the sun is at due north. So it is like about, if this is the pole, these are the poles, this is the equator, this is the Tropic of Capricorn. So the sun is almost at the tropic because today is the 15th, not the 21st. So let's assume the sun is about here, like almost. And we get the lines go like this, the lines of this of the sunlight. No, it's a little bit like this. Anyway, I hope you understand. So now let's calculate what is the distance from their location to the North Pole, and then we'll add the distance to the sun. No, then we'll calculate the distance of the sun because it's not the solstice. So we need to do a little bit of trig up there. So let's start with the sun, okay? So today is the 15th of December. The year is not, that doesn't matter. The solstice is, in case you don't know, let's see, winter solstice. The winter solstice is the 21st. So 21 minus 15 is 8. 6. How do you count with 8? So we are 6 days away from the solstice. We know the length of the fall. Let's see when was the autumnal equinox. The autumnal equinox was 2024 was the 22nd of September. So from here to here, how much time we have? How many days? Let's see. It was Sunday and today is also Sunday, which means we have a number of days that is divisible by 7 without any remainder. So it is like 84 days. Right? September has 30. So from the 22nd of September to the 22nd of October is 30 days. And from the 22nd of October to the 22nd of November is 31. And then another 30. But we must subtract 6. So we have 30, 31, and 24. That's interesting. So here we got 85 or 84. Okay. From Sunday to Sunday, it's if we include Sunday or if we don't include Sunday, but there it was midnight, so we do not need to include Sunday. So it's 84, not 85. So okay, so we are 6 days away from the equinox, and the length of the season is, as we said, 85 plus 6 is 91 days. So now we must calculate the location of the sun in its yearly path of the sky. So we know, let's do like this. We know this is the equinox, this is the equinox, and this is the equinox next year. This is summer solstice, this is winter solstice, or if we're in the south hemisphere, the southern hemisphere, it's in reverse. So this is, as we know, a sine wave, and we're almost here. We're 6 days away from this point, so we're about here. If you can see what I'm drawing. So we know it's a sine. If we start from here, where this is spring, this is summer, this is autumn or fall, depending how you write it, and this is winter. We're on the almost here. So we're 6 days before the solstice. So we can either call it a sine or minus sine, it doesn't matter. And we start from here. If we want to start from here, we can use the cosine. So this is what we'll do, because instead of subtract and do a sine of 85 divided by 91, we can do a cosine. Its result the same number. You can see it, okay? You can see, okay, we're on degrees. You see 85 divided by 91, and the sine of that trig, sine okay, this is yeah, we have 0, we have 4 zeros here. No, okay, no, I'm sorry. This is 85 divided by 91 equals, and this, the sign of this. Okay, this is 0.016. And you will see if I do the cosine of the complement of this, we'll get to the same number. We have 0.016. The rest doesn't matter. You can see 6 divided by 91 equals that, and the cosine of that, 6 divided by 91 cosine. Something wrong. 85 divided by 91 sine of that. That's weird. Wait a minute. Why I don't get the same number? If I'm... Oh god, no, I have it. I have to do a 1 day after. I can't do the same day. I can't do the same day. Okay, it either I do 6 and 86 or 85 and 7, and that's the point. Okay, you see, 7 divided by 91, and I do the sign of this, and that's what I get if I subtract it from 1. Okay, this is the number I got, but with a negative sign. So I'll do the 6 and I'll just go with that. So 6 over 91 and the cosine of that, and it is 9. Okay, no, I don't want that number. I will multiply it by 23.5, which is the degrees the sun goes. So I want to know how many degrees the sun is off from the equator, and the sun is like 23.5 degrees. It's basically the same number. I don't think I have to do any subtraction, I'll just go on with 23.5 and get on with it. So this was basically irrelevant for what I'm trying to do. Now we'll try to figure out their distance from the subsolar point. So we know the subsolar point is 23.5 degrees, which means basically the Tropic of Capricorn. In the next few days, nothing will change. Not in any degree that's relevant to what we're trying to do. So they are at 79 degrees, 44 arc minutes, and 24 arc seconds. So now let's do the conversion to decimals. We know that 24 of 60 nautical miles. We know a nautical miles is 1,852 meters divided by 60 multiplied by 24, and this is the meters they are away from. And now we need to add the nautical miles times 44. So they are at 82 kilometers out of 1 degree, which is 111 kilometers and 120 meters. So we will keep it here and add the degrees. Plus 79 degrees multiplied by the number I just said, and 120. Okay, which means they are 8,860 kilometers and 708, almost 9 meters away from the equator. So minus 10,000 to get the distance. Oh, I'm sorry. Divided by 1,000 to get the kilometers. The meters doesn't matter. Okay, now minus 10,000 So there are 1,139 kilometers away from the pole. Okay, let's write it. Distance from the South Pole is 1,139 kilometers. The meters doesn't really matter, but you know, let's add that anyway. Plus 29. So we know the elevation angle of the sun, which is basically on the Tropic of Capricorn, and we know they are at the distance from the sun. We need to add this to this. Okay? I don't think you get what I'm saying. We know they're away, on the other side of the pole from the sun, because it's local solar midnight where they are. It's not midday, as I used to do this experiment. They are in midnight, local solar midnight, not local solar noon. So at local solar midnight, we need to add this distance, not to subtract it. Okay, you get it? So let's do it. We need to add that one. Let's reverse it. Huh? No. No. Anyway, 1139.29. What? 1139.29. Now we need to add that distance to the distance of the sun from the pole, which is plus 90 minus 23.5 is 66.5 times 111.12, which means their distance from the sun at local solar midnight is 8,528 kilometers and 770 meters. It's their distance from local solar, from the subsolar point at local solar midnight. So let's write that also. We have distance from what's with my English, subsolar point is 8,528 kilometers and 770 meters. Now let's do the calculations. I mean the trick, the real thing we've gathered here to do. Okay, so we know this is the length of the stick, this is the length of the shadow. Now let's calculate the angle. So we do this 185.5 over 828 is the arctangent, is the tangent of the angle. So we need to make an arctangent of this angle. So 1 85.5 over 828 equals arctangent. We get 12 degrees, 12.627 degrees. Okay. Arctangent to this equals 12.627 degrees. 12. Now, we know this is 12 degrees, which means basically we're talking about this angle, okay? The angle of the sun from where they are. I'll make it bigger so you can see. If, let's say, this is how it goes, this is where they put their stick, this is the shadow. I made it okay like this. It's way out of scale, but it doesn't matter. And we need to calculate okay, the sun is about here, and we have this part of the globe, this arc of the globe. Okay, so if this is 12 degrees, we'll subtract it from 90 and we should get this distance. Okay, now let's do it. 90 minus 12.627 equals 77. Now let's see the beauty of it. If I multiply it by what I should get, you know this number, right? We can see it here. It's almost the same number, 8,500, and this can be the deviation is basically the fault of the equipment. But we know this number, right? Now let's go a little bit back. We have 90 minus 12.627, which is 77 degrees. This is the head angle of the triangle. Okay, this is 12 degrees, this is 77 degrees. Let's write it. This is 12.627 and this is 77.373. So we know this angle gives us this distance. Now we will divide this distance by this angle. Okay, not the one that I calculated, but what they have calculated according to the location. We just figured out. We converted to decimals. So we need to know how many kilometers per angle, and then we will multiply it by 360. So we have 28.77 divided by 77.373, and we have this amount of kilometers per degree multiplied by 360, and we have the circumference of the Earth, which we are about 330 kilometers off the real number. Now, okay, so it is 39,682 kilometers, 0.5. Okay, this is the circumference. And if we want the radius, we'll divide that by 2. pi. Okay, this is divided by pi, now divided by 2. And we get radius of 6,315. The real number of the radius that we have calculated ages ago is 6,371. You see, the difference is basically minuscule regarding the raw equipment they have used down there in Antarctica. So MCToon, this is for you. I hope you are happy with the results. I'm so happy for you. You've been there, and I will make another one soon. I mean, in the next few days, with the result I've got from my measurement at the same moment you did your measurement there. If you don't know what I'm talking about, this is what I did, this is what he said, and I have measured the same thing at my home. Let me get it a little bit closer. Okay, I have measured, I have it on my okay, let's see, I'll show you. I've took another measurement. Okay, this is it. It's it's not exactly a stick. It's a contraption made by my son. And this is the tape measure of the shadow, which is 157. But okay, I took a picture of that. I don't know if you can see. You can see it here. But the thing is, the floor in which I did that measurement is not exactly perfectly level. It's about 2 degrees inclination. So I had to figure out if this diagonal is 257, what's the length of this? And I got 183, and I've measured the height of the sun at the same moment and the azimuth to get it right. It was 128 degrees from north, which is a little bit south from due east. Okay, and I'll make another one in the next few days after I do the calculations of this, and I'll do it again with you guys. Thank you all for watching MCToon. I hope you like it. It was a pleasure to do that, basically, and it was nice to do another video in English. I hope you all like it, and I'll see you soon. Thanks, guys.